Hello my dear students, today we discuss about the exponential distribution. This is one of the distribution in unit 4. Already we discussed the unit 3 revision like uniform distribution and normal distribution concepts over. So exponential distribution, this is one of the distribution in unit 4. So you should more focus on all these areas here. So define exponential distribution, obtain 4 central moments of exponential distribution, also calculate beta 1 and beta 2. Define exponential distribution, derive MGF of exponential distribution, hence find its mean and variance. So define exponential distribution, derive the expression for its distribution function, show that exponential distribution has a lack of memory property or memoryless property. Today we discuss all these concepts. This exponential distribution is very easy. So the function of exponential distribution is f of x is theta e power minus theta x greater than or equal to 0, theta greater than 0. So based on this, you should consider the distribution function. It is in the this here derive expression for its distribution function in 17th one. Distribution function is there. So distribution function in the sense it's like capital F of x. Capital F of x is p of x less than or equal to x, integral minus infinity to x f of x dx, integral minus infinity to x theta e power minus theta x dx, theta considered as common. So there integral e power minus theta x means e power minus theta x by minus theta. Theta get cancelled, minus e power minus theta x 0 to x. It gives minus e power minus theta x minus of minus plus e power 0. 1 minus e power minus theta x is the capital F of x, which is the distribution function of exponential distribution. Like that you should derive. So definition already over. So memoryless property later on I'll discuss. Before going to that, just check the 15th and 16th. Define exponential distribution, obtain 4 central moments of exponential distribution, also calculate beta 1 and beta 2. Define exponential distribution, already defined. Once again check it. If x is a continuous random variable, it follows the exponential distribution. If the PDF is given by f of x is theta e power minus theta x, theta greater than 0, x greater than or equal to 0. So based on this, you should find the first 4 central moments of ED. Also calculate beta 1 and beta 2. How to calculate the central moments here? First you should calculate the non-central moments. How to calculate the non-central moments in the sense you know very well. So mu r dash is defined as expectation of x power r, integral x power r into f of x dx, integral x power r into theta e power minus theta x dx, theta considered as common, integral x power r into e power minus theta x dx, integral x power r plus 1 minus 1 e power minus theta x dx. It is of the form of gamma integral. You should substitute the gamma integral and simplify it. There will get mu r dash. After getting mu r dash, there will get the mu 1 dash, mu 2 dash, mu 3 dash, mu 4 dash and mu 4 dash, all the 4 non-central moments. After getting the 4 non-central moments, you should go through that central moments. Mu 1, mu 2, mu 3, mu 4. Mu 1 is very familiar for you. Mu 1 is 0. Then mu 2 is defined as mu 2 dash minus mu 1 dash whole square. Substitute that respective functions there. So then mu 3 considered, mu 3 dash minus 3 mu 2 dash mu 1 dash plus 2 mu 1 dash whole cube. So substitute and simplify. Like that mu 4 find mu 4 dash minus 4 mu 3 dash mu 1 dash plus 6 mu 2 dash mu 1 dash square minus 3 mu 1 dash power 4. So then basing on that you should substitute and simplify. After getting all the 4 central moments, you should go through that beta 1 mu 3 square by mu 2 cube, beta 2 mu 4 by mu 2 square. Substitute that respective values and simplify it. It gives the beta 1 and beta 2. It is our first concept in the exponential distribution. Like define exponential distribution, derive MGF of ED, hence find its mean and variance. So definition already over. Derive MGF. So MGF in the sense mx of t. Mx of t is defined as expectation of e power tx. It is a continuous random variable. That's why integral e power tx into f of x dx, integral e power tx into theta e power minus theta x dx, theta considered as common, integral 0 to infinity e power, so take the common and simplify it, it gives mx of t. It is mgf of exponential distribution. Then find its mean and variance. Mean is expectation of x. How to get expectation of x? Through mgf, in the sense mx dash of t at t equal to 0. mu2 dash is mx double dash of t at t equal to 0. Then mu2 is mu2 dash minus mu1 dash whole square. So here how to find mx dash of t, mx double dash of t, in the sense it's the derivations like. So it is about mgf and find its mean and variance. This is about the exponential distribution. One small thing is there here, lack of memory property or memoryless property. State and prove memoryless property. It is our main important statement and proof here. So memoryless property of exponential distribution. So first observe the statement here. If x follows exponential distribution with the parameter theta, then lack of memory property of ed is given by p of x greater than or equal to t plus x, given x greater than or equal to t is equal to p of x greater than or equal to h. See here, apply the condition. Once we apply the condition also, no condition in the RHS means, so there is no memory for the exponential distribution. That's why here, as per the process, there we consider conditional probability p of a given b. P of a given b, in the sense p of a intersection b by p of b like. So you should take the t and h are the real numbers and greater than 0. So exponential distribution with parameter theta. The PDF of exponential distribution is given by f of x is a theta e power minus theta x. It's familiar only. Now consider p of x greater than or equal to h here. Integral h to infinity f of x dx. So integral h to infinity theta e power minus theta x dx. Theta is the constant. E power minus theta x by theta. Theta get cancelled and substitute there. Minus e power minus infinity plus e power minus theta h. It is e power minus theta h. It is RHS of our statement. Like apply the conditional probability here. Once we apply the conditional probability, p of x greater than or equal to t plus h given x greater than or equal to t. So p of x greater than or equal to t plus h intersection x greater than or equal to t by p of x greater than or equal to t. Now check the numerator here. So x greater than or equal to t, suppose 2 onwards is there, 2, 3, 4, 5 like that. H is suppose 3, 2 plus 3 means 5. 5 onwards, 5, 6, 7 like that. Means what's the common here, in the sense 5 onwards. Means greater than or equal to t, greater than or equal to t plus h, means the common area is greater than or equal to t plus h. That's why p of x greater than or equal to t plus h by p of x greater than or equal to t. Already you derived the denominator here. So e power minus theta t, like numerator is also like our equation 1. That's why e power minus theta into t plus h, e power minus theta t into e power minus theta h. So first term get cancelled, e power minus theta h. It is equivalent to our equation 1. So that's why p of x greater than or equal to t plus h given x greater than or equal to t is e power minus theta h. It is p of x greater than or equal to h. Hence proved. So means it is the memoryless property. So you should derive the both LHS and RHS here. So and simplify it, in the sense it gives the same result only. That's why p of x greater than or equal to t plus h given x greater than or equal to t is p of x greater than or equal to h. This is about the exponential distribution. You should more focus on exponential distribution, all these concepts. Okay, thank you.